Okay, so those first segments were about masses that were accelerating, and that last one that we did was actually the first time that we've had to draw a free body diagram, a body on which all the forces are acting. As we continue down this list, we'll actually have to do this a couple of more times. So we've got a book that's sitting on a table. I'll start to draw these diagrams then on each time. Here's our table. Okay, it's got a book on here. Okay, here's our book, and it's a 5 kilogram book. I'll usually put down the mass somewhere close to this, and the forces that are going to be acting on it are the weight, and then there's the force that the table has to provide to keep it sitting there, and that's usually what we call as normal. Now, that book is not moving. It has a mass of 5 kilograms, but if I'm going to put these in here like this, that mass is going to be 5 kilograms times the acceleration, which is 0, which is nice because that ends up becoming this side. The mass times the acceleration is right there. And now for the forces, I have to put both these two forces in there. So that's going to be the normal force minus the weight is equal to 0. So the normal force is just going to end up becoming, let me get that, come on. The normal force is going to be equal to the weight when I move this over. Okay. So the weight we already knew because it's a 5 kilogram mass. That comes from mass times gravity of any object. So that's going to be 9 times 5.8. Sorry, 5 times 9.8. That's going to become 49 newtons. The normal force is 49 newtons. Don't get the two ends confused. That's the normal force with the newton as the metric unit. Okay, so that's how we're going to solve number 4.